Hi students, welcome to the next topic from electrostatics, which is electrical potential and capacitance. That's the second chapter we are handling right now. And last class we have discussed about the different models like type 1, type 2, type 3 and the different models of a combination of capacitance and the advanced problems from the combination of the capacitance, which are really quite important for your Neet and JE examinations. Today we are going to see the next important topics, which is called dielectrics. So write down the headings: dielectric. So there are frequently questions are coming from this area, which is called a dielectric. What is in short a dielectric? Dielectric is the material in which we are placing between two plates of the capacitor. You know, capacitors will have two plates, right? Both positive and the negative plates are available for a capacitor. So within the capacitor, between the positive and the negative plates, we are placing something, and that material is called dielectric. If you are not placing anything, just air will be there, air medium, then air medium we call it as a dielectrics. Okay, so we are going to see what is the effect of placing a dielectrics in between them. So let's see. So first we will define what is called dielectric. Is a material placed between two plates of the capacitor. So the material in which we are placed between the plates of the capacitor is called dielectrics. So far we have learnt about dielectrics. We have a positive plates, we have a negative plates. All our positives will be here, all our negatives will be here. So between the positive and the negative plates, each of the plates will have area of cross section A and the distance between them is D. This is called a parallel plate capacitor. This is what we have already learned in the last topic. Okay, so here the value of capacitance C equal to epsilon times of A divided by D. This is what we already learnt. Here if I am asking you what is the dielectric, as I defined before, is a material placed between two plates of the capacitor. This is a two plates, plate 1 and plate 2. What is the material here placed? I have not placed any specific material. What is already available will be here, normal, our air medium. And here in this case air is called the dielectric. So I can say in this specific example, dielectric is equal to air. It is not only that it should be always air, it can be any type of material which will be available between the plates of the capacitor, but in this example dielectric is air, for whose capacitance is equal to epsilon A by D. This is what we have learned so far. Now here what is the difference we are going to learn means, instead of air, if something is placed extra, what is going to happen. Okay, so hope you understood this one. Okay, so now we will see dielectric. This is an heading, subheading: dielectrics other than air. Dielectrics other than air. Okay, you cannot see an exact heading like this on your Ncert textbook or any other reference textbook. This is I consolidated for your easy purposes. So we are placing an dielectrics other than air. So C will be here. We have two plates of the capacitor, positive plates will be here and we have the negative plates will be here. Between the plates of the capacitor, we are filled with a dielectrics material. This is any kind of a material in the sense that is an insulator. So what will happen in this case means, normally if it is an air, so this is an air capacitor, positive plates, nothing is filled in between them. So there is a electric field is exist. Electric field is always start from positive and go into negative. Okay, here the electric field is given as E0. But when you placed dielectrics, what will happen means, due to the presence of the dielectrics in between them, the electric field will be reduced. What will happen means, whenever a positive voltage will be given here means, on the vicinity of, suppose you can assume our dielectric is placed like this, for example. So I placed a dielectrics will be like this. This is my dielectrics. So if you place like this one, what is happening means in the vicinity means in this border. In this border of the dielectric and induced, we have learned about our first class of electric charges and electric field, charging by induction, charging by conduction. So here what will happen, due to charging by induction, a negative charge will be formed on the left side. Whenever a negative will be there, what will happen to the other side? A positive. Other side, a positive charge will be here. So the other side, it is negative. So positive, negative, positive, negative. So whenever air is there, there is no induced electric fields are not formed. Whenever if air is not whenever air is there, only this positive and only this negative will be there. So other than air, if I placing anything else, any other material, what will happen? This positive will induce a negative and this negative will induce a positive will be here, and this positive and already negative. Okay, so this positive and the negative is already there. So this positive will induce a negative and this negative will induce a positive. So extra one negative strip and one positive strip will be formed if you are placing any material other than air. That is the speciality. So what will happen here, as I told before, already one electric field will be created by the air medium, which is called E0. I am just giving E0 to understand this is for air. But what will happen, because of this induction property, the dielectric, the dielectric positive and the dielectric will create another electric field opposite to that. This is just against that, which means the dielectric, once we are placing, will create another electric field which will opposes the existing electric field. Okay, so we will get a total electric field, E net electric field. E net electric field, I will get it. So this net electric field, because of this E0 and E will be there. Because of this combinations, a net electric field will be formed and whose value equal to E0 by K. E0 divided by K. Now, if I am asking you what is the electric field all over will be here, you know it is a difference of E0 minus E value, and that is equal to E0 K. E0 times of K. So what is the electric field will be here? I can say then the electric field will be here is equal to E0 by K. What is the electric field will be here? You will say E is equal to E0. So here the total electric fields are reduced. Why? Because of the dielectric. Then the next question will ask how the dielectrics will reduce the electric field. Answer is quite simple. Because of the positive plates and negative plates, electric field will be formed from left to right. And whenever you place a dielectric, this will induce a negative charge here, and this negative charge will induce a positive charge will be here. Because of this one, another electric will be formed like this, and this is opposite to the E0. Because of this E0 and E effect, total electric field formed, this is an experimentation result. So the total electric field formed will be equal to E net equal to E0 by K. Now I have a questions to you. What is the electric field whenever a dielectric is placed? I can say E0 by K. What is the dielectrics when an air medium is placed? E0. So remember this point. Electric field, whenever you see the presence of an electric field, dielectrics. Okay, the value of K. K is the strength of dielectric. Dielectric means insulator. Dielectric is simply called insulator. Okay, so insulator means the insulating property means to the prevention of the current. Current will not be allowed, right? Insulator. So E0 by K. If it is a pure insulator, like paper, mica, ceramic, these kind of materials, if you are using, then K should have a particular value. K is holding a particular value. So I am going to write two important points will be here. Not two important points, 4 points I am going to write. So, and one point is these 2 points, these two differences, and second point is the value of K is specific for an insulator. So what is the value of K for an metal? Metal is a pure conductor of electricity. So the value of K for a metal, K is equal to infinity for a metal. K and the value is equal to infinity for a metal. So in case of K is equal to infinity for a metal, I can say instead of just by hearting this expressions, I can say the in a metal surface, within a metal, what is the electric field? Within a metal, electric field will be equal to 0. So suppose if you are assuming this is a metal, instead of placing a dielectric, if it is a metal, then what is the value of E? E will be equal to 0, but E0 will be there. So to have it 0, what is the value of K? K should be infinity. If K is infinity, only total electric field will be equal to 0 whenever a metal in place. So we have to summarize all these points. Okay, so hope you understood the concept. Now it's a time to write a neat note points. We need to write a 4 points will be here. Okay, based on the 4 diagram. So our first point, if it is an air medium, okay, minus, if this is an air medium, electric field value is 0, capacitance value epsilon times of A divided by D. Okay, electric field value C is equal to electric field in the value E is equal to, I can say electric field equal to E0. That's all. E is equal to E0, C is equal to epsilon A by D. Second point, I have placed some dielectrics in between them. This is the positive plates and this is the negative plates. The distance between the plate is D, of course, and its area is A. Then in this case, the electric field E equal to how much will come? E0 by K. Okay, capacitance formula we need to derive. I will take into later. So capacitance formula we need to derive. Okay, so this is a purely a dielectric. And whose value will be equal to K. So capacitance will be here, C is equal to epsilon A by D, and second one, a dielectric, E become E0 by K. So I move to my third point. Okay, so what's my third point is like the same structure, but in between the plates I placed something called a metal. The value of K is equal to infinity. Remember this, E is equal to E0 by infinity, which is equal to 0. This is the positive plates and this is the negative plates. So these three information should be there on your notebook. So K will have a specific value, K should have a different value, and we want to know now the capacitance value. If it is an air, this is a metal, this is a dielectric. If it is air, we know the capacitance value epsilon A by D. But what will happen if a dielectric is placed? Okay, hope you remember these 3 points. Okay, so we'll move to the next topic, that is actually our fourth point. As I told before, right, we have 4 points will be here. So 3 points already we have written. Our fourth points we are going to derive it and we will write it. So we'll move to the fourth point. Fourth point, instead of 4 point we can write capacitance. We will write fourth point little after some 5 minutes. Capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor when a dielectric K is placed. When a dielectric K is placed. When a dielectric K is placed to what is the value? So we know electric field will be equal to, whenever a dielectric will be there, okay, we know the voltage equations. V is equal to E into D. Okay, E into D means here I have to say voltage difference. Why? Because I have 2 plates, positive plates and negative plates. When going from here to here, the potential V is reducing. Voltage is reducing, right, from positive to negative. So that the potential difference is called delta V, and E become for a dielectric is E0 by K into D. Okay, so now we know the formula for capacitance. Q is equal to C into, in this case it is delta V. So C will be equal to Q divided by delta times of V. We have to substitute, will be here Q divided by delta V is E0 by K into D, which is equal to Q by, what is E0? E0 means sigma divided by epsilon 0 between the two plates. This already we have seen, right? Into D, and this is K. Again we have simplifying Q. What is sigma? Surface charge density, charge by area. So Q by D, A, epsilon 0 K. Q and Q get cancels. Epsilon A K divided by D. This is the capacitance of a parallel plate capacitor when a dielectric K is placed. Okay, if it is air, when a air dielectrics வரும்போது C is equal to epsilon A by D. This I am giving C naught just to understand it is air. So with respect to the capacitance, here I am giving Ck. So I can say Ck will be equal to how many times of K times of C0. This is important. Capacitance with dielectric is equal to K times of capacitors with air dielectrics. So air dielectric is epsilon A by D. To understand it easily, I am giving C0 because I am using the notation called E0 for air. So C0 I am using. So whenever I placed any other materials which having a specific dielectric constant, then Ck is equal to K times of C0, which means that what? Air capacitor is good or capacitor with a dielectric is good? Capacitor with dielectric is good, because if you have a air, normally the value of K should have certain value, some positive value will be there. Okay, it should have some value. So for example, as of now we are assuming the K is equal to 10 for the easy simplicity. When K will be equal to 1, sorry, K will be equal to 10. In that cases, if the normal air capacitor, if I placed, I will get C is equal to epsilon A by D. Suppose I am assuming this is equal to 10 microfarad. This is equal to 10 microfarad. I am assuming this. You don't want to write this one. This is for an example. So when K is equal to 10, then Ck will be equal to 10 into 10, which is equal to how much will come? 100 microfarad. What this means to us, which means if you have a capacitance with air capacitor, you have a capacitance value that is very less. But if you placed a dielectric, your capacitance is increased by how many times? K times your capacitance will increases, and this is the main property of this one. So a capacitor with dielectric is good because it will give more capacitance as compared to that of capacitance with air capacitor. This is the highlight will be here. Okay, hope you understood why we are preferring capacitance with dielectrics, why we are not preferring capacitance with normal air. Just two plates will give a small capacitance, but if you fill it between the plates with something, either mica or any I can say plastic capacitors, I can say ceramic capacitor. Ceramic is a very commonly used metal items, and sorry, not a metal items, very commonly used dielectric, which is an insulator items in a capacitor manufacturing. Okay, you can see this capacitor as I told before in some sessions. If you look into the fan, one of your ceiling fans, and most of the fan it will have, but ceiling fan it's very easy to see will be there. There is a cup will be there, right? On the 3 leaf there is a cup, that is the holder will be. If you lift that holder and you can see a white cylindrical shaped structures will be here. That is basically a capacitor. Whenever normally if you buy a new fan, and once we turn the regulator like 1 2 3 4 5, if 5 is the highest speed, from 1 2 3 4 5 its speed will be increases. So capacitor is playing a major role in delivering and storing the charges. Whenever, suppose if you buy a fan and in your home the fan is running for maybe some 4 to 5 years, once you put it to the 5 even though after 5 years its speed is not that much sufficient. In that cases, a simple method is you have to change the capacitor. Okay, so be careful, you never go and change us, call some electricians and they will change you for you. Okay, because it's risk. Okay, risk in the sense you have to connect the polarity in the right way. So there are many things will be there. So remember, whenever in your home, okay, as a small engineer now itself from physics, if your capacitance, if your fan speed is very less, of course it is recommended to change your capacitor. It will not cost much, it's very cheap only. Okay, so we'll move to the next topic, which is related with the capacitance. Okay. Okay. Oh, fine. Now we are going to see, now we have seen a capacitance which is filled fully, right? A capacitance which is filled fully. Next one, we are going to see the next topic, partially filled dielectrics. Partially filled dielectric. Okay, so what will happen? Capacitance we are going to see for a partially filled capacitor. So this is the positive plates as usual and this is the negative plates. So I am filling certain area of the plates. Okay, which is the total distance between the plate is d and the thickness of this structure is small t. Okay, we are going to fill this informations to you. So C will be equal to, okay, so first of all we want to know what is the voltage and from there we will start, right? Voltage will be different. So the voltage difference delta V will be equal to, here one electric field, what is the value? E0. What is electric field will be here? E0 by K. Okay, so general equation is delta V is equal to E into D. So here there are two different electric field, E0. So the E0 is spanned over an area. What is this length? D minus T. Total is D. Here it is T. So this is D minus T. So E0 into D minus T plus what is this? E0 by K. So E0 by K spanned over an area of T. So it is T. Okay. So what we can do, E0 is taken outside. So D minus T plus T divided by K. Next, we will normally go with our capacitance equations and Q is equal to C into delta V. So C will be equal to Q divided by delta V. Okay, we are substituting Q divided by delta V. Delta V is this one, E0 into D minus T plus T divided by K. Okay, we are substituting for E0 as we know this formula. So Q divided by, Q means what? Sigma divided by epsilon 0, sigma by epsilon 0. So Q divided by A into epsilon 0, sigma, for instead of sigma I am substituting charge by area, and D minus T plus T divided by K. Q and Q will get cancelled, and the balance steps writing will be here. This epsilon will go to the numerator. So it become epsilon A divided by D minus T plus T divided by K, and this is the value of capacitance. Okay, C is equal to epsilon A divided by D minus T plus T by K. This is very important. This formula is very important. So a partially filled dielectrics with dielectric constant K is given by the formula epsilon A divided by D minus T plus T by K. What is called T? T is the thickness of the dielectric in which I have filled it. Okay, hope you understand the formula. Okay, there are stuffs in which we have filled it out and that has to be written will be here. Okay, fine. Partially filled dielectrics. Cool. Okay, so next, okay, next topics we are going multiple partially filled dielectric, multiple partially filled dielectrics, which means I have a positive plates, I have a negative plates. Total distance between them is given as d. So I have filled one dielectrics like this, and this is K1. I have filled another dielectrics like this one. Okay, not very close to the border, somewhere in between, like this, with some gaps I have filled it. And this value is K2. We need to find out the total capacitance in this case. How to find out the total? Multiple things. Here multiple means previously we have taken only K. Now we have like K1 and K2. Any number may comes, but this is only for two cases. What's the starting step? Delta V is equal to E into D. Okay, this thickness is taken as T1, this thickness is taken as T2. So here we have E0, here we have E0 by K1, here we have E0, here E0 by K2, electric field, here E0. So E0 will be there in the three places. So first I will write for E0, E0 into D minus, what all the area? What is this gap, this gap, this gap? Total D minus T1 minus T2. If you are removing T1, T2 area, D minus T1, T2. That area will contains E0 plus. E0 by K1 into, what is the spanning of that area? T1 plus E0 by K2 into, what is the spanning of that area? It is T2. Okay, what we'll do? We'll take E0 common. So I got D minus T1 minus T2 plus T1 by K1 plus T2 by K2. Okay, so we'll go to the capacitance formula. We know the capacitance formula, C equal to Q by delta times of V. Delta V is the potential difference between these to this point. Okay. Okay, so Q by delta V, what is called Q? Q, charge on the capacitor, delta V E0, E0 instead of E0 I am writing sigma by epsilon 0, which means Q by A into epsilon 0. D minus T1 minus T2. Everything is the same steps, but slightly electric field will be changes, so accordingly formula will also changes. This is what we are doing. So Q and Q will get cancelled, epsilon A will go to numerator. So our formula is epsilon A divided by D minus T1 minus T2 plus T1 by K1 plus T2 by K2. Remember this formula. This is for multiple. In the previous example, what we have seen, we have only one dielectrics K1. K1 is equal to K there and T1 is equal to T will. There is no K2, there is no T2. So T2 is not there, there is no K2 is not there. So these two terms you can remove. So D minus T plus T by K previously we got, just previous steps. Okay, that is for one dielectrics. But now here we have, what's the difference? Here we have multiple dielectrics. So remember this formula. This is quite easy to apply while you come up with certain questions. Okay, D minus T1 minus T2 plus T1 divided by K1 plus T2 divided by K2. This is with multiple dielectrics, and this is the total capacitance of this parallel plate capacitor, which is holding K1 and K2 of dielectrics having the thickness of T1 and T2. That's the answer for this one. Hope you understood, right? Good. So we will go and do one question. Okay, fine, perfect. We'll do one question to understand this concepts in a better way. Okay, so let's go with an example. Example number 1. Just to understand this concept, we are writing an example. See, we have two plates, positive plates, negative plates, negative, 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 negative. Two plates will be here. We applied the formula C is equal to epsilon A by D minus T1 plus minus T2, T1 by K1 plus T2 by K2. So we know for a metal K2 is infinity, I have written d minus t1 minus t2 plus t1 by k1 plus t2 by infinity. Because K2 is a metal, so its dielectric constant is infinity. So what is the whole factor will be here? This is 0. Something by infinity is 0. So final formula is epsilon A divided by d minus t1 minus t2 plus t1 by k1. This is the value of the capacitance. Okay. Hope you understood this formula in a very clear way. If it is metal, means infinity. If there is no metal, means you can apply the formula and you can find out whatever you required it. Okay. Fine. Okay. Okay. Next, we'll do something else also. Okay, next example, the second example. Some other problem. Positive plates, negative plates, positive plates. I fill it with a dielectrics like this. This is D by 2 area. Total area is D. Dielectric is K. What is the capacitance? Only one dielectric. So immediately we can write the formula C is equal to epsilon A divided by D minus T plus T divided by K. That's all. We'll substitute will be here. Epsilon A divided by D minus T. T means what? T is D by 2. So D by 2 plus what is T? Again thickness D by 2 K. Okay. So we have to simplify this. So epsilon A divided by D minus D by 2 means D by 2 plus D by 2K. So again we can simplify epsilon A divided by D by 2 will be here 1 plus 1 by K. This is the answer for this question. Okay, here there is only one dielectrics. There are no two dielectrics will not be there. So we are finding the value of the capacitance for this structure which having only one dielectric. Okay, hope you understood. Okay, next we are going to see something different in the sense example number 3, third example. This is like little graphical. Okay, so write down the question. Draw the variation of E and V for the variation in distance. For the variation in distance for the given structure. For the given structure. Okay, so I will explain to you very clearly, don't worry. This is a dielectric. This is a dielectric is placed will be here. Okay, and whose value is equal to K1, and this is thickness T1. No, not thickness T1. Let me make it like this. This is called D. This is called another D, and with another D distance, I have another item is placed, and this is a metal. Okay, and this value is also D, and this value is also D. So everything is D meters apart. Okay, which means this is D, which means this is also D. This is what plates? Positive plates. This is negative plates. Perfect. So what we are going to do here means, here we are going to draw a graph which shows the variation of electric field. That is one set of graph. Another set of graph which shows the variation of potential with respect to distance. So let's start with okay, let's start with electric field. Okay, distance x. X means from here to here. This is the distance called x will be here. So first, if you see what is the dielectrics will be here, it is E0. What is will be here? E0 by K. What is? It's a metal. So it is electric field is 0. What is will be here? E0 by K. This is the variations we are going to draw. So E0 on the top level. Okay. Then E0 is reduced. This is E0 by K. And of course this is 0 point. So first level up to, so here distance have to plot D and 2D. And this is 3D, and this is 4D, and this is 5D. So 0 to D distance, it is E0. So this is the lines. So 0 to D distance, it is E0. Next to D, next means D to 2D. How much is the value? E0 by K. So this will reduce and this will go like this. This is E to 2D. So this over, this over. Next one, 2D to 3D. This value is what? E0. Again, it will rise to E0 like this. 2D to 3D, E0. Next one, 3D to 4D, this range, 3D to 4D, it is 0. So it will just fall down, metals fall down like this. And 4D to 5D, again E0 by K. So again E0 by K, like this. Okay, I'll repeat once again. If you have got confused, nothing will be there. Here it is E0. How much distance? 0 to D. So 0 to D, E0. Next one, E0 is reduced because of the dielectric. How much times? E0 by K. E0 by K is the reduced value. So this is from where to where? Here it is D. For the next D, so already we are here. For the next D means D to 2D. This distance, 2D distance, here it is E0 by K, this line. Then the 2D to 3D, it is E0. So from here it goes to the top. And we are reached will be here. So we are at 3D. From 3D to 4D, metal. So electric field will be equal to 0. Dielectric constant is equal to infinity. So is equal to 0 means comes down. It will touch us on the 0 line. The last one, 4D to 5D. 4D to 5D, here it's a mistake, right? 4D to 5D, it is just is what called air. Air means it should go to the top. It should go to the top. This is metal 0, then it is air. Here there is no dielectric, so it is E0. So E0, E0 by K, E0, 0 and E0. So this will go to the top like this one. So this is the variation of graphical representation of the electric field. Okay, hope it is clear. Now what we need to draw in the next time? Potential. You have to remember the questions very clearly. Question is asking about the potential. Question is not asking about the potential difference. Question is not asking about the potential difference. Potential. Question is asking potential, not potential difference. Potential difference means between this point and this point. Potential is here one potential, here one potential, here one potential, here one potential. So question is asking about the potential, not potential difference. Be careful. To find out the difference, we need 2 points. To find potential, we need only 1 point. So of course we know from here, if you are going to here, potential is reducing. So I am marking the points D, 2D, 3D, 4D and 5D. So just I am marking the lines for my easy simplicity, so that it will be easy where I will know like 4D and the last one is 5D, like this. Okay. So here electric field is E0. If electric field will be equal to E0, which means potential is also equal to E0. But one point you have to remember, we are going from here to here. If you are going from here to here means potential is reducing. But potential is reducing a constant value. Okay, so from left to right we are going and the potential. So first for the first D, I am starting from positive high potential, I am going towards negative side. So here I have potential, so going towards negative side, potential is reducing. What is the potential reduces? The potential reduced value, this value, now it reaches from top to on bottom position. This difference is E0 into D. E0 into D. So topmost potential is V, then this point I can mark it as V minus E0 into D. This is a potential reduced. After that, again I am going, now I am here, from again I am going towards right, so potential is also reducing. So potential is also reducing. So how much it is reduced now? from here to here, from here to here means E0 by K into D. So what I can say about these points? What I can say about V minus from the top, how much it is reduced? E0 by D minus one more E0 by K into D. This much it is reduced. Now again will be here the third point. Third point, it is again reduced this much. And what is this value? I can say V minus E0D from the top. First one E0D reduced, second one E0 by K into D reduced, third one E0 into D reduced. This much it is reduced. Fourth one, this is important. In the fourth one, from 3D to 4D, this distance. So we have covered 3D, this much area, 1D, 2D, 3D we have covered. Now we have 3D to 4D metal. For metal, electric field will be equal to 0. Potential is equal to what? Electric field is equal to 0 means potential is equal to 0. No. We have written some formula. Delta V is equal to E into D, which means when electric field is equal to 0, potential difference is equal to 0. Potential difference is equal to 0. But what is potential? V is constant, V is same, V is not changing means if you are taking V1 minus V2 which is equal to V minus V which is equal to 0. Potential difference is 0 whenever electric field is equal to 0. But potential, question is potential, not potential difference. So potential difference is equal to 0 but potential is not 0, potential is constant. So this will be in the straight line. This is very important. So we are reached will be here. After that again E0. E0 means this will reduce us further. So it will come to this point, and what is the value? Instead of making here it is dump, I am writing will be here. From the top, how much we have reduced? V minus. First this one reduced, that is E0D. Second one, this is reduced, minus E0 by K into D. This is over. Then third one, this is reduced, minus E0D. Finally, this is not reducing, then this is reducing, that is E0 into D. This much times it is reduced. So this is the variation of potential, not potential difference. Variation of potential along the distance from left to right for a parallel plate capacitor. So this graph is important, this diagram is important. This may come like this one for IIT JE students. This is very important. For IIT JE students, this is very important. Normally this kind of model of sometimes they will ask you to draw such kind of graphs for advanced examinations. Sometimes they will ask you to interpret some information from this one. I mean from here, what will be the metal, what will be the item placed during this period, it is metal. So sometimes from the graph you have to apply the logic in a reverse way, and you have to find out what is the corresponding dielectric will be comes within this segment, it is metal. So this kind of models questions may comes for IIT JEE mains and advanced examination. For Neet students also this is important. Very typical questions exactly like this have not seen yet for Neet, but chances will be there. Okay, so this is quite important, especially for advanced entrance examination and mains also it is important. And for Neet students, the variation of electric field is already there. I guess it's for an AIMS paper previously, now it is merged with the Neet anyway. So this is also important for both for medical and engineering students. Okay, so hope you understood the concept very well. Great, we'll move to the next topic. Next topic in the sense, yeah, of course it's next topic. Two major things we are going to see will be here. Series and parallel combination of capacitance with different dielectrics. So that is little tricky, but yeah, it's easy. Okay, so far we have not learned anything by heart, right? All are some concepts only. Okay, So let's start with series combination of capacitance with two dielectrics. So I am going to teach you with the two dielectrics, okay, but it should not be two for examination, maybe three, it may be four, it may be two also, but this is an example. From this example we can start to do any problems. Two capacitance which are connected, this is K1 and this is K2. This distance is d by 2 and this distance is d by 2. This is our positive plates as usual and this is our negative plates. What is a capacitance? If this kind of model, if you have seen like this cut, then it is a series capacitance. We know 1 by C equivalent equal to 1 by C1. Okay, before that I am going to write, generally you know, right, series combination of two capacitance means what? Tell me. C1 C2 divided by C1 plus C2. What is C1? C1 is a capacitance will be here. I told whenever a dielectric is placed, capacitance become that many times of dielectrics. So K1 into, okay, so K1 into epsilon A divided by distance. What is the distance for this one? D by 2 into K2 into epsilon A divided by D by 2 whole divided by K1 into epsilon A divided by D by 2 plus K2 into epsilon A divided by D by 2. We have to simplify this. That's what our duty. Epsilon A by D by 2, will take it left hand side from here and 1 will get cancel it out. So it become epsilon A divided by D is keeping will be here. Okay. So epsilon A by D by 2, one factor will get cancelled from numerator and denominator, 2 will be here. What will comes on the numerator? It is K1, K2 divided by K1 plus K2. I can much better way I can write epsilon A divided by D into 2 times of K1, K2 divided by K1 plus K2. This is important. Series combination of capacitance which is having two dielectrics will come up with this formula 2K1 K2 divided by K1 plus K2. If there are three things will be here, one more capacitance will be here. So what will do? You have to take the formula. Okay, 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. Here only 1 by C1 plus 1 by C2. That's what I have taken, C1 C2 divided by C1 plus C2. But three capacitance will be there, means 1 by C1 plus 1 by C2 plus 1 by C3. Okay. Okay, fine. Next one. Okay. Fine. So next one, symbol concepts again we are going to apply will be here. Okay, but this is one way of solving the questions, but I need to give you another methods. The same questions I am solving but with another method. So I am writing alternate method. I want to show you one more method. This is what we have learned so far, the same stuffs. K1, K2, distance is D by 2, distance is D by 2, positive plates, negative plates, multiple dielectrics placed. I know the capacitance formula epsilon A divided by D minus T1 minus T2 plus T1 by K1 plus T2 by K2. This is what is the formula we have learned, right? You can apply this formula very openly will be here. So it become epsilon A divided by D minus T1 T2. What is T1 T2? T1 is D by 2, T2 is D by 2. So it is D by 2 minus D by 2 plus D by 2 by K1 plus D by 2 by K2. D minus minus D. So this will become 0. So epsilon A divided by D by 2K1 plus d by 2k2. D is taken outside. So epsilon A divided by D into. Okay, so what will come? 1 by 2k1 plus 1 by 2k2. You can take it LCM. You can take it LCM and you have to simplify this one. So epsilon A divided by D into 2k1 2k2. So 2k1 plus 2k2 whole divided by 4k1 k2. Once you simplify, the steps will be further here. What you will get? Epsilon A divided by D into 4k1 k2 go to numerator. So this 4 and out of this 2 will get cancelled. So 2k1 k2 divided by k1 plus k2. The same thing we have learned, right? Same thing only we have seen so far yet. The same formula, you will get it with an alternate method. This is also applicable. Hope you got the beauty of this method and the previous methods. Okay, we'll move to the next topic. So now we have seen the series combination. Of course, what will be the next? Yes, you are right. You thought right. Whenever I told the word called series, of course the next word will come, that is called parallel combination of capacitance. Okay, so only the series word I am changing. So we need parallel combination of capacitance. So with multiple dielectrics. In that cases, what you can see means distance will be the same like this. This type of model is a parallel combination. This is K1, this is K2. Distance between them is D. So C equal to epsilon A divided by, okay, it's a two capacitance in parallel connection. So C equivalent equal to C1 plus C2. C1 is epsilon A divided by, how many times of epsilon? K1 times epsilon A by D plus K2 into epsilon A by D. But what is the difference? When you cut like this one, the total area of cross section is changing, right? The total area is changing. So A become A by 2, A become A by 2. But distance will be the same. So what is the common will be here? Epsilon A by D is common. So it become K1 by 2 plus K2 by 2. So here K1 by 2, there K2 by 2 will be here. So generally totally K1 plus K2 whole divided by 2. This is the equivalent capacitance when two capacitance are connected in parallel. Always remember, if the cut like this, if distance is not dividing, then it is a parallel connection. If the cut is like this, then distance is dividing, then it is called a series connection. This is all about the dielectrics. So many things we have learned today. In this sessions, many things we have learned today. What is called a dielectrics? Capacitance will be increases, but electric field, what will happen to the electric field? E0 by K times reduces. If it is metal, what will happen to electric field will be 0. Then we have seen different combination, partially filled with one plate with a different partially filled capacitors, like multiple things will be there. What will happen, sir? Then we have seen some series and parallel combination. We have seen some graph. All these are, if you ask me what is important out of this one, sir, what is the most important one, I will say all are equally important, because we don't know where you will get one question. So enjoy the study. Hope you understood what I have taken today. So yeah, bye.